Yeah, good everyone. So we're going to continue from our previous class. Here we're going to learn a very important tips on how to get the period, the group, and the block of elements in the periodic table. Now to start with, do not forget this is what we call our electron configuration, and I've showed you this in our last class. So how can I use this to determine the period group and and block of an element? So let's take one example. So if I have sodium. So sodium has atomic number. What do we have? Atomic number 11. And please mind you, I'm going to use two methods so that you pick anyone which you're verifying with. So for sodium, how can I get the periodic group of what? Of sodium? Very simple. Method one, I can use what? Shell. So with the shell method, you know that a shell, the first shell, had, how many electrons did I want to fill? I want to fill about 11 electrons. So now let's go. The K shell takes maximum of how many electrons? That is what? 2 electrons out of 11. So your L shell will take how many electron? That is what? 8 out of 11. And mind you, what the thing is going to left with. So you're going to left it what? With 1. Don't forget, this is the inner shell, very close to the nucleus. So these are the penultimate shell before the valence shell. Why here? These are what? Valence shell. So your valence shell is the outermost shell of an element, while the penultimate shell is a penultimate shell before the valence shell. So what can I use this one to get? So with this alone, I can use to determine the period and group what of an element. How? By counting the number of shells, and two, by using the valence electron. So from here, how many shells does sodium have? Sodium has about 2 each shell. So that becomes what? Period. So is in period 3. So this let me know that, okay, I get the period of an element by counting the number of shells it has. Why? What's going to be the group? So for the group, like I said, you're going to use what? The valence electron. So what's the valence electron? So that's what? 1. But you use the Roman figure, and that becomes what? I. So this lets us know that, okay, in periodic table, the location of sodium in the periodic table is a period 3. And what's your period? So your period they are horizontal rows, while group are what? Vertical, what do you have? A colon. So this lets us know sodium is in group 1, and so is in group 1, and likewise period 3. This is method 1. But this method was able to give us what? A block. So the one that can easily precise a block is using what? This electron what configuration. So if that is also clear, let's see another method. So we say now using this. So let's go. We want to fill 11 electrons. So I'll be having 1 s2, 2 s2. So 2 s2. So how many electrons have I filled out of 11? 4. So the next one follow is what do you have? 2p. What do you have? 6. So I haven't reached what? 11 electrons. 2 plus 2, 4. 4 plus this making 10. So I haven't reached what? 11 electrons. So what's the next? What's the next orbit after this? So the next orbit after this says what? It's 3s. Now 3s what? 3s has the capacity to take what? Electron. But how many electrons do you think we are left with? How many electrons we are left with? We only have what? We have 1 electron to complement what you have this 10 electron, making 11 electron. So this becomes what? 1. Now, see, get to know. Picking the last, I told you. So picking the last energy level, or let me say picking the what? The last shell. So which is this? So this lets us to know that what? This number here, like I told you, this is your your energy level. So this are your energy level. So from here, the 3 that is here serve to be what we have a serve to be the period. So period 3, good one. What about this one? Yeah. So the 1 is what we have the group. So that gives us group 1. Use Roman figure. And the last one is the block. So what block? Your block is the orbital, is the orbital. So yeah, so we have a block. Or let me just say S block. So made like that. S block. So very simple and very, very direct.